So let's talk about a technology that is just completely changing the game for robotics. It's letting developers build and perfect robots in a virtual world before they even exist in the physical one. We're talking about NVIDIA's Isaac Sim.
I mean, just think about this for a second. What if you could teach a robot to do something really complex, let it make a million mistakes, and get its programming absolutely perfect, all before you've even turned a single physical screw? Well, that incredible promise is exactly what we're going to dig into today.
Because, let's be real, building intelligent robots is tough. It is really tough. Testing them out in the real world is insanely expensive, it takes forever, and just one little mistake can mean costly damage or months of delays. You just can't scale when every single test requires physical hardware.
So how in the world do you get around that physical bottleneck? Well, you create a virtual world, a totally physically accurate digital sandbox where robots can learn and fail safely and endlessly. And that is exactly the solution that NVIDIA Isaac Sim brings to the table.
Okay, so what is it officially? The textbook definition says that Isaac Sim is a reference application for developing, simulating, and testing AI-driven robots in physically based virtual environments. It's all built on this really powerful platform called NVIDIA Omniverse.
Yeah, I know, that's a bit of a mouthful, so let's make it way simpler. Here's the best way to think about it. You know how pilots use flight simulators? They can train for thousands of hours, face every crazy emergency you can imagine, all without ever leaving the ground. Isaac Sim is exactly that, but for robots. So how does a developer actually get started with this? What's the process? Well, it can be broken down into this really clear three-step workflow. You can think of it as the journey that takes a robot from just a 3D model to a fully trained, intelligent machine.
All right, so the whole process really boils down to three key stages. First, you've got design, where you build the robot in the simulation. Second is tune and train, which is where the AI gets smart. And finally, you deploy that intelligence to a physical robot out in the real world. Let's break each one down.
First up is design. And the cool thing is developers don't have to start from scratch. They can just import robot models from the popular design software they're already using. Now, the real magic here, the thing that makes this all possible, is a technology called Universal Scene Description, or USD. Just think of it like a universal translator for 3D models. It lets you take a robot designed in one program and a gripper designed in another and just seamlessly snap them together.
Next is the absolute heart of the system, tune and train. This is where the virtual robot actually learns. The simulation's physics engine is so good, it makes sure the digital world behaves just like the real one, everything from gravity to friction. It can simulate super complex sensors like cameras and LiDAR. And, this is the big one, it can generate an endless river of training data. This lets the AI learn from millions of scenarios in just hours, a process that would take years in the real world.
And finally, we have deploy. This is the moment the virtual becomes real. All that amazing training isn't just stuck in the simulation. Isaac Sim connects directly to common robotics frameworks like ROS2. That's kind of the operating system for most robots, letting developers just seamlessly copy that trained AI from the simulation straight onto a physical robot.
So we've seen the workflow, right? But what's the secret sauce? What makes it all possible? Let's pop the hood for a second and take a quick look at the core tech that powers this whole platform. Everything, and I mean everything, starts with something called the Omniverse kit. The easiest way to think about this is like the fundamental engine or maybe even the operating system that Isaac Sim is built on top of. It's the toolkit that provides all the core power for creating these incredibly complex virtual worlds.
And the language that everything in this world speaks is Universal Scene Description, or USD. You might have heard of it. It was actually created by Pixar, and it's basically the HTML for the 3D world. It's this open standard that lets all these different tools and assets talk to each other flawlessly, which, as you can imagine, is absolutely critical for building these kinds of simulations.
And this spirit of collaboration is really baked into the platform's DNA. There's a key quote from the developers that highlights this perfectly. They say the goal is not to compete with the software people already use, but to collaborate with and enhance it. It's all about adding this powerful simulation layer that just makes existing tools better.
Okay, so we've covered the what and the how. Now let's tie it all together and talk about the why. Why is this whole simulation-first approach such a massive game changer for the future of robotics?
It all boils down to one single critical concept: sim to real. The whole point, the ultimate goal, is to close that gap between the virtual and the physical.
to make the simulation so ridiculously accurate that a robot trained inside it can perform its job in the real world perfectly on the very first try.
And when you get that right, the real-world payoff is just immense. This tech lets companies create digital twins, these perfect virtual copies of physical robots or even entire factories. We're talking about accelerating development pipelines from months down to just a few days and allowing for complete end-to-end testing before a single piece of expensive hardware is even powered on.
And all of this leaves us with one final, pretty mind-blowing thought. We're creating a world where robots can get a lifetime of experience in just a matter of hours. So, when a robot can learn, adapt, and pretty much perfect itself in a virtual world, what will it be truly capable of in ours?